Okay, let's have a look at a trial and improvement question. In this particular case, we've got x cubed plus x take away 1 equals 0. We're asked to solve this by trial and improvement to one decimal place. We're also told in the question that the solution lies between 0 and 1. Okay, so we're doing it to one decimal place. If the solution lies between 0 and 1, then we make a guess. And the first guess would be guess x equals, well, halfway between 0 and 1 would be a sensible first guess, 0.5. What you do now is you take the left hand side of the original equation, LHS for short, and you simply replace the x with 0.5 in the left hand side. So the left hand side, instead of x cubed, would become 0.5 cubed, plus instead of x you get 0.5, take away 1. You just work out the left hand side. Now if that guess is the correct answer to one decimal place, when you work it out it should equal 0. So we've got to work out 0.5 cubed plus 0.5 take away 1 and see what it gives. So on a calculator, 0.5, if I cube that, plus 0.5, and then take away 1, and you get an answer which is equal to minus 0.375. Okay, so you cube that, then you add 0.5, and then you take away 1. Now that there, you see, is a negative number which is smaller than 0. We want it to equal 0, so that answer there is too small. Too small. So with it being too small, we now make an improved guess. This is where the trial, that's the trial, the guess, first guess, and now the improvement comes. The improvement is a better guess. So we have a second guess. 0.5 is too small. It would be sensible now to go to something like 0.7 or 0.8. Okay, don't go to 0.6. Go to 0.7 or 0.8. Okay, and we're going to have a look at the left hand side and see what we get. So this time the left hand side will be x cubed plus x take away 1, 0.7 cubed plus 0.7 take away 1. Let's work out what that is. 0.7 cubed plus 0.7 take away 1. And that actually gives us a positive answer of 0.043. Well, we want it to be 0, so that's gone a bit too big. So you could see that a guess of 0.5 gives an answer which was too small, a guess of 0.7 gives an answer which is positive, which was a bit too big. So, 0.5 too small, 0.7 too big. A sensible next guess would obviously be 0.6, which is in between the two. So you now have that the left hand side, it will be, instead of x cubed, 0.6 cubed, plus x, 0.6, take away 1. So 0.6 power 3 plus 0.6 take away 1, and you get an answer of minus 0.184, which again is too small, because it needs to be 0 and it's gone to negative, so 0.6 is too small. So at this stage, this is what you need to do to get full marks. You can see, if I do a little sketch here, that 0.6, there it is too small. I do a little sketch, 0.7, where is it? There it is, was too big. Now what I want to do is find out which of those two is the answer that is the best answer to use to one decimal place. 0.6 or 0.7. 0.6 is too small, 0.7 is too big. What you need to do is actually now work out the halfway value, which is 0.65, and see what happens for 0.65. So I'll do that here. So I'm going to guess x equals 0.65. So the left hand side will become 0.65 cubed plus 0.65 take away 1. Here we go then. 0.65 power 3 plus 0.65 take away 1, and you get an answer of negative 0.075375, I think. So you can see that that is too small. It should be 0, it's a negative, so it's too small. So that means that the halfway point in between 0.6 and 0.7, 0.65, is too small. Well, if 0.65 is too small, the answer must obviously be closer to 0.7 than it is to 0.6. So therefore, our final answer, x, if we're trying to pick between 0.6 and 0.7 being the best answer, 0.7 is closer to what we want. So x equals 0.7 to 1 decimal place. And there you go, there's the answer. Just don't fall into the trap of thinking where it says 1 decimal place that these things here have to be written to 1 decimal place. No, it doesn't matter how many decimals you could work these too big, too small answers out to. It's the guesses that you're looking for, because the guess is the answer to the equation which you want to 1 decimal place. So, and also don't forget, the final calculation you need to do is the halfway point between 0.6 and 0.7, which is actually 2 decimals, 0.65. That has 2 decimals, but it's only used to help you determine which of the two, 0.6 or 0.7, is the best one to use. We found that 0.7 was the best one to use. Okay, in the next video I'll have a look at solving a trial and improvement question to 2 decimal places.